This is a worked solution to AQA Physics P1 June 2014 higher tier paper, question 7. Question 7 describes a setup where a power supply is heating an immersion heater which is inside a copper block. The joule meter will record how much energy is being transferred to the immersion heater, and the thermometer reads how the temperature of the copper block increases as heat is supplied. The graph shows us temperature increase against energy transferred, and we can see the relationship is nonlinear. On the next slide, we're asked how much energy is transferred when the temperature is increased by 35 degrees. So if the temperature goes from 0 to 35 degrees, if we draw along a straight line here and then drop down here, we find that it is exactly between 30,000 and 40,000. So that is 35,000 joules transferred, which is the answer to 7b here. 7a asks us how energy is transferred through the copper block. Copper being a metal means the free electrons lead to conduction. 7c asks us to calculate the specific heat capacity. Specific heat capacity has the formula that the energy transferred is equal to the mass of the substance being heated times the specific heat capacity times the temperature rise. Now, in part B, we said that 35,000 joules were required to raise the temperature by 35 degrees. If we're using 2 kilograms of the substance, we don't know the specific heat capacity, the temperature increase was 35 degrees. If I write this out fully, I have 35,000 is equal to 2 times 35 is 70 times C, and I can calculate the specific heat capacity by dividing each side by 70, so 35,000 divided by 70, which gives me a specific heat capacity equal to 500, and the unit of specific heat capacity is joules per kilogram degree C. And again, I could work that out because this side of the equation, the units of joules, kilogram degrees C, I've divided joules by kilogram degrees C. It doesn't give the correct value for the specific heat capacity of copper, and that's because it's not fully insulated. So a lot of the heat that's provided to the block will actually not just raise the temperature of the block, but raise the temperature of the surroundings as well. So energy is lost to the surroundings.